Hey, Mr. Cowan.
Hi, Dylan. How are you doing tonight?
I'm good. How about you?
Good.
Good.
All right. Let's see. We want to start at 25.
Sure. Yeah, let's do that.
Okay.
Alright.
Sounds like you still have a bit of a cold.
I do. Gosh, it's just cleaning on. I got it around like Saturday night and then still hasn't gone away, so
Supposed to be a pretty nasty flu going around, although Colorado
that's
was one of the few states that it hadn't hit yet.
Oh, really?
Well,
Oh.
I saw a map like 2 days ago of the United States, and it's everywhere except for just a few states, and we were one of the few that it hadn't hit here yet.
Oh, wow. Alright.
So, all right.
Yeah,
With
you
this
think we'd be on first.
25,
Mm-hmm.
there's a number of ways to do 25.
Okay.
Um, Probably the way they would like you to do it is to use the rules of exponents. They even say so in the directions, the properties of rational exponents.
Yep.
So the first thing we should do is do what?
Um, so we would multiply the
Right.
exponents together, right?
Yeah, and I can also do this, just
Mm-hmm.
so you realize.
Okay.
Same problem.
Mm-hmm.
And the advantage of doing it this way is, well, let's apply. What's the new numerator going to be?
So the new numerator is going to be 2 to the minus sixth.
Okay. And the denominator is 3 to the minus 3.
Yep.
Now, what you can always do with a negative exponent is move
Mm-hmm.
the thing to the other side of the fraction bar.
Okay.
Whether it's in the numerator or the denominator does not matter. So
Right.
I can do this. I can move the 3 to the negative 3 to the numerator and change it to 3 to the positive 3. And I can move the
Okay.
2 to the negative 6 to the denominator and make it 2 to the positive 6.
Cool.
Okay. Now, it says simplify as far as possible. I imagine he wants you to do these. Uh,
Yeah.
so
Mm-hmm.
what is 3 cubed?
So 3 cubed would be 27.
What is 2 to the 6th?
Um, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is
You hit,
1.
you hit it.
Oh, okay, 64.
It's
Okay.
64. Yeah. These are, it's not a bad idea to memorize the powers of 2, at least up to maybe 7.
Okay.
2 to the 7th, 128.
Mm-hmm.
But certainly up to 2 to the 6th.
Okay.
Now, that's as simplified as it gets. I can only divide this by 3's and 9's, and I
Right.
cannot divide this by 3's and 9's. So
Mm,
that's the final answer.
cool.
Now, 26 was done exactly the way I would do it. I don't know if this is your writing or teacher's.
Yeah, it's my writing.
It's your
Mm-hmm.
writing.
Yep.
What is this root 3 of 7 over 2?
That's supposed to go with 32. For some reason, it
Okay.
got put all the way on the other side, which it confused me.
I was
Like,
confused as to what that was.
yeah,
That's the problem,
like
32.
I was,
Yeah, that looked
I
like
was,
awfully good handwriting. I was going to say, how did you write that so well?
I was like
It's because it's,
sitting in class, like looking at it, and I was like,
yeah.
well, I thought that was the answer for a second. I was like, how the heck do you get 37 root 2? Like that just doesn't make sense. And then like I realized that it was part of
Well, it's
32.
cube root is what
Yeah,
that 3 means, is the cube root
cute.
of 7 over 2.
Yeah.
Um, all right, well, let's go in order.
Okay.
26,
Cool.
you broke it up into 9 times 8, which is good
Uh-huh.
because 9 is a perfect square number. So that
Yep.
becomes 3 root 8, And root 8 can be broken down further. So you pull a 2 out and you end up with 6 root 2. Perfect.
Cool.
27. We got the cube root of 9, which we can't do anything with,
Nope.
times the cube root of 6, which we can't do anything with. However, what is that equal to?
Cube root of 54.
Yeah. And notice now we can kind of do stuff with it.
Right.
Let's factor 50. Are there any perfect cube numbers that will be factors of 54?
No.
About 3 cubed?
It's 3 times 3.
27.
Yeah. Oh, okay.
So 27 is a factor of 54. So I got the cube root of 27 times the cube root of 2.
Oh, okay. I see
That
what. Okay.
is 3. So I end up with 3 cube root of 2.
Sweet.
Okay? And that's pretty cool because, like I said, we couldn't do anything with cube root of 9 or the cube root of 6. That would be fully simplified. But when we multiply them together, it turns into 3 times cube root of 2.
How would you get the 3 in front of the cube root of 2?
Because that's what the cube root of 27 is. That's all I did.
Oh, which is 3. Okay, okay.
Yeah, they confuse the issue here by putting a lot of 3's in there.
Right.
But, yeah, it's just the
Okay.
same way you do square roots. In other words, it's the same process as you did on number 26, only we're doing cube roots. So we're looking for numbers that are perfect cube numbers. Well, you don't have to memorize perfect cube numbers very far up. There's 2 cubed is 8, 3 cubed is 27, and 4 cubed is 64, 5 cubed is 125, and that's about it. If you memorize those, that's going to work for almost every problem on this page.
Okay.
But it is a good idea to know those and have those memorized.
Yeah, definitely.
Okay.
Cool.
Look at 28. Let's see. Let me blow that up a little bit so I can make sure I'm doing it right.
Yeah, sorry about I don't know what it was. My pictures kept turning out blurry for some reason.
No, this is fine. I can read it. Yeah, as long I just had to magnify it.
Okay.
So how are we going to do this? We got division of the base going on.
Yeah, so you just subtract the exponents.
Okay. So what is 1/7 minus a minus 6/7?
Minus 5/7.
No, look at that carefully.
Wait, so it's 1/7 minus a minus?
Minus a minus.
So you would add them. Yeah.
You don't want to drop one of those negative signs. If you drop negative signs, which is a pretty common problem in math, is when you're overloaded with negative signs, people tend to drop them.
Gotcha.
Especially when you're subtracting a negative number. That's when people really drop them. And it's easy to make the mistake you made. But this turns into plus. 1/7 plus 6/7 is 7/7 or 1. So that turns into 3 to the 1 power, or just 3.
Which is 3. Yeah, which is your answer. Cool. Okay.
The next one, let me write it out so I can ponder it a little bit.
Okay.
Notice I cannot do anything with that part.
No.
I don't have the same base. I don't have the same exponents.
You
got to have the same base or the same exponents before you can do much with it.
Okay.
However, because the whole thing is to the minus 1, now let's see what happens.
Okay.
What's the first thing you want to do?
Get rid of the parentheses.
Yes. So what does this turn into?
So this would turn into 2 to the minus third times 3 to the second.
Times 2 to the 1.
Right.
We still have this 2 over here, which you can write as 2 to the 1. Okay, now we do have the same base between these two.
Uh-huh.
So what does that become?
So that becomes 2 to the minus second.
Times 3 to the plus 2.
Mm-hmm.
And now to simplify that, I think we just need to turn it into numbers. What is 2 to the minus second equal to?
Minus 4.
No.
Actually, no, that'd just be it'd just be 2.
Always remember one thing, Dylan. Negative
You
exponents never mean negative numbers. There is no relationship. In fact, they're almost always positive numbers.
Okay.
It means reciprocal. So that's the same as 1 over 2 squared.
Gotcha. I remember this.
3 squared is 9.
Mm-hmm.
So we end up with 9 over 4.
Cool.
Okay.
Okay.
30. 1 over 6 to the minus 1/5. Well, remember what I said you can do with negative exponents on either side of the fraction bar?
Yeah. You would multiply. Well, yeah, you'd multiply by the reciprocal.
No, not multiply.
You would
move. Is what I want to do is I want to move that to the other side of the fraction bar. Well, here's the fraction bar, so I'm going to put it up here with a positive exponent.
Uh-huh.
That's the answer.
Oh, sweet. Okay. Right.
Always remember that when you have a negative exponent and you have a fraction, and you always have a fraction because you can always put a 1 under something.
Right.
And then you can just move it to the other side and change the exponent so that it's positive.
Sweet.
56 to the 1/3 divided by 7 to the 1/3. Don't have the same base, but I got the same exponent. So how else could I write this?
So you subtract them.
No. You can only do that when you have the same base.
Oh, when you have that.
This is not a same base problem.
No.
However, I can...
You can divide, right?
Yeah, exactly. In other words, I can turn it into that.
Yeah.
And you're going to find that's going to be very helpful.
Yeah, definitely.
What's 56 divided by 7?
That's 8.
And what's the cube root of 8?
2.
There's your answer.
Cool. Alright.
32. We have the cube root. I think that's what that says.
Yeah.
Okay.
Of 7 over 2.
A lot of people would say, well, well, there's nothing wrong with that answer at all. But if I do this, it's the cube root of 7 divided by the cube root of 2.
Right.
Now I
so
got to multiply. What's my problem with that answer?
You can't have a cube root on the denominator.
Well, you can't have an irrational number in the denominator. And this gives us an irrational number. So this is a little harder to rationalize than square roots. Let me write it like this.
Okay.
Now we want to turn the bottom into 2, right?
Mm-hmm.
What do I have to multiply top and bottom by in order to turn the bottom into 2?
In order to turn the bottom to 2.
How about 2 to the 2/3?
Okay.
And that's going to give us what?
So that'll give us So,
all over.
yeah.
So, gosh, hard to imagine that's the answer.
Yeah.
But the only difficulty in this problem is the fact that you have an irrational denominator.
Right.
So I think this is the answer. I don't see anything else I can do here. I see a little bit I can do. Let's see, 7 to the 1/3, and I can make this 2 to the 1/3 times 2 to the 1/3. See how I can do that?
Uh-huh.
I take
Yeah.
my 2 to the 2/3 and just make it that.
Uh-huh.
Now, I don't have the same 3 bases, but I got the same 3 exponents in the numerator.
Right.
Which means I can say 7 times 2 times 2 all to the 1/3.
Mm-hmm.
What is that? That's 1428 to the 1/3 over
Mm-hmm.
2. And 28, that doesn't have any perfect cube factors.
No,
So I don't think I can reduce that.
I don't think so.
So, and if you want to give the answer back with radical signs, because they gave you the problem with radical signs, then that's
Mm-hmm.
going to look like this. There's your answer.
Okay. Cool.
Perfect cubes are 8, 27. Nah, 28 is not divisible by either of those. So,
No.
all right. Let's have
So
a,
that's your answer? Yeah.
yeah, I think that's the answer. And that was a little tricky. In other words, I
Mm-hmm.
didn't see it right away. I was inclined to go with what I had. I've erased it now, but
That's all right.
in other words, I started out with 2 to the 2/3 in the numerator,
Mm-hmm.
which I couldn't do anything with those 3 numbers. But once I separated it into 2 to the 1/3 times 2 to the 1/3, now
Uh-huh.
I got the same exponent, and I can just multiply the underlying numbers.
Right.
Okay,
Cool.
33.
All right.
Let's take this part first. What's that equal to?
That's equal to um I'm not sure.
Any number raised to the 0 power is equal to 1.
Is equal to that.
1.
Okay.
Always 1.
Okay.
Including 0 to the 0th power.
Uh-huh.
This amazes most everybody. That's equal to 1.
Wow. Oh, interesting. That is kind of
So
weird.
any variable to the 0th power is just 1. So I don't have to do any math at all there. That's 1. So now I'm multiplying it by -3 to the -2.
Mm-hmm.
How am I going to do this?
You would put it 1 over -3 over -2, so that'd be 1 to,
Well, give me the complete answer. This is the complete answer. In other words, it's 1 over the quantity -3 to the +2.
so it'd be 1 over 9.
Yep.
Cool.
Times 1, which is still 1 over 9.
Cool.
Okay.
Okay.
34, how should I rewrite that?
Um, let's see here.
You have to apply this outside exponent to every term in the parentheses.
Right.
Let's
So it would
start with
be
the 6, and then we'll go to the x, and then we'll go to the y. What's 6 to the -2?
36.
No, 6 squared is 36.
Isn't that what? Oh, wait. Isn't that what this is, though?
6 to the -2.
Oh, which is 1.
No.
6. So that'd just be 6.
Okay. Let's cover how to handle
Anything,
negative exponents. You're having a real hard time with negative exponents.
yeah, it's just equal to the,
Tell me what it's equal
to 6.
No.
Oh, no, that's not it.
It's reciprocal to the positive exponent.
Oh, well, 1 over 6 is 1 over 6
over 6 squared.
Yeah.
That's the way you do it every single time. Okay? So negative exponents should no longer be giving you trouble.
No.
Okay, well what's 1 over 6 squared equal to?
1 over 36.
Okay.
Cool.
So that's the number part. Now apply it to the x variable. Now we're still in the numerator, so I'm going to put this in the numerator, but what's the new exponent of the x?
Squared.
Multiply the minus 2 times the minus 2.
Which is 4.
That's the new exponent for x. And what's the new exponent for y?
And then the exponent for y would be y to the minus 6.
And I'm going to start by leaving it in the numerator because that's where it was. But now what can I do with it?
Put it over 1. So it'd be y.
No, just move it to the denominator. You don't need to put it over 1. We already have a 1 here. You just need to move it down to the other side of the fraction bar. Remember, that's what you do with negative exponents, is you move it to the other side of the fraction bar, which puts it there to the positive exponent. That's all you do. Only 2 things. Move to the other side of the fraction bar and make its exponent positive instead of negative. I don't need that 1 anymore. So this is my final answer. X to the 4th over 36 y to the 6th.
Cool. Okay. All right.
So let's...
Almost.
Okay. What's my new x in the numerator?
X to the 3rd minus 3rd.
No. You're doing this part right here.
Yeah.
What do you do with the exponents when you're dividing?
Subtract.
What's 6 minus a minus 2?
8.
So that's x to the 8th, and that takes care of both of those terms.
Right.
I'm going to put a fraction bar there.
I'm
going to leave my z in the numerator. What am I going to do with my y?
Put it in the denominator.
With what exponent?
Positive 2.
Okay.
Cool.
34.
Or
36, I meant. Sorry.
Yeah. No, you're good. Okay. This would just be x, right? Because the exponents will just cancel out.
Well, what do you do to the exponents when you're multiplying the base?
You add them.
Okay. So what do you get when you add 3/4 to minus 3/4?
0.
So now you have x to the 0. What's that equal to?
1.
Okay.
Cool.
37.
Okay. Yes.
I'm going to separate it. Since the whole thing is to the 1/4, then I can do this. Y to the 8th to the 1/4 divided by 16 to the 1/4. Well, what's y to the 8th to the 1/4?
Y to the 8th to the 1/4 would be 2. Y to the 2nd.
Y squared. And what's the 4th root of 16?
2.
So the answer y squared over 2.
Okay.
Okay.
Cool.
All right, now we get to kind of the tricky ones. I'm glad we had time to at least get them.
Yeah, me too.
And there's two ways to do this.
Mm-hmm.
I'm just going to explain both of them to you and let you choose the one that you prefer.
Okay.
First of all, do your numbers first, then do the x's, then do the y's, then do the z's.
Mm-hmm.
What's the cube root of 27?
3.
So now I'm down to this.
Mm-hmm.
What's the cube root of x to the 9th?
X to the 3rd.
Yeah.
Okay.
So that takes care of that.
Mm-hmm.
Now, what's the cube root of y to the 5th? Here, let's look at this separate down here.
Okay.
Cube root of y to the 5th. Can I pull anything out?
No.
It's like
Well, you can pull up the y, right?
Because why don't I rewrite this like the cube root of y cubed times the cube root of y squared. That's what the cube root of y to the 5th would be.
Okay.
And now what's that equal to?
And then that's equal to, wait, so,
Cube root of y cubed.
just y.
Okay? But it's times the cube root of y squared. So the cube root of y to the 5th turns into this. In other words, pull out as many whole y's as you can, and whatever you have left over stays under the cube root sign. In other words, if I had the cube root of y to the 7th, well, I can pull out a y squared, leaving, in other words, that's the same as the cube root of y to the 6th times the cube root of y.
Okay.
Right? And then the cube root of y to the 6th is y squared. So the answer to this would be y squared cube root of y.
Okay. And that's your final answer.
Well, now let's go back to your problem. I was just showing you how to do these where you have unusual exponents, which, hold on.
Okay.
Okay. Meant to erase.
It's all good.
So here's where we're at. We've pulled out the x cubed. Now we're going to pull out a y, leaving behind a y squared. Make sure you understand how I got there.
Yeah.
Now let's look at the z variable. Can I pull out a z?
Let's see here. Yeah, just z.
Leaving behind what?
Just z to the first.
Well, right. The cube root of z.
Right.
So my final answer to this problem is 3x cubed y z outside the radical sign, and inside the radical sign I've got a y squared and a z left over. So there's the answer.
Cool.
Now, that's kind of a hard way to do it. I think the best way to do these is to convert everything to exponential so that you end up with 27 x to the 9th, y to the 5th, z to the 4th, all to the 1/3 power. That's what I mean. In other words, eliminate the radical sign.
Right.
And now I'm going to multiply. I'm still going to take the cube root of 27, which is 3, but I'm just going to multiply exponents. 1/3 times 9 is 3, so I immediately get my x to the third.
Yeah.
1/3 times y to the fifth is y to the 5/3, z to the 4/3. Now, your teacher probably not going to like that answer, even though there's nothing wrong with it. That would be an easy answer and something you'd get almost instantly without all of that other stuff that I had to go through.
All that time, yeah.
Thing is that I could also rewrite this as 3x cubed y times y to the 2/3. You see how I separate the 5/3 into y times y to the 2/3?
Yep.
Times z to the 1/3.
Okay.
Now, that and that go outside of the radical sign, so I end up with 3x cubed y z. And if I want to put my radical sign back in there, underneath it goes y squared times z. So I can get to the same answer. Whether I have to do this down to there, I'm not sure whether your teacher would insist that you do that or not. If they wouldn't, then, boy, this is by far the easier way to go.
Yeah, definitely.
Convert everything to fractional exponents and just multiply them.
Okay.
Or apply them.
All right. Okay.
I know it's 8:30, but I see some on here we haven't talked about. Let's see. I think you can do 39.
I do too.
Convert it to the 1/4 power and just multiply the exponents.
Right.
If your teacher accepts that as an answer, I'm not sure they will.
Yeah. He never said he wouldn't. Well, I mean, unless he says it, like, I think.
I don't know. Yeah, I got a feeling they want you to go the full mile there and give them. In other words, the rule I tend to follow on problems that students give me is if the problem is given to you with a radical sign, then you give the answer back with the radical sign.
Right.
And in order to answer that last problem with radical signs, you have to go through all of the separation.
Okay.
You don't want to give the answer y to the 5/3. You want to give the answer y times the cube root of y squared. Okay? All right.
Okay.
Let's make sure you know how to do this problem right here.
All right.
Think of apples and oranges. That is an apple. So is that. Well, I can add and subtract apples. I can multiply apples by oranges, but I can't add and subtract apples and oranges. But I got 2 apples here. So if I got 2 apples and I'm subtracting 6 apples, what do I got?
You get -3 to the cube root of 5th.
Hold on. What's 2 apples minus 6 apples?
-3 apples.
2x minus 6x is what?
-3x.
Now it's minus 4x.
I mean 4. I don't know why I keep saying 3. Yeah, it's my 4x.
Okay. So we got 2 apples minus 6 apples. That's minus 4 apples, and an apple is a cube root of 5.
Right. So and that's your answer.
So you can add and subtract these things as long as they are the same things.
Cool.
Next problem is I got 2 apples plus 1 apple. So I've got 3 of whatever these things are I call apples.
Right.
Next problem is I got minus 3 of these things plus 2 of those things. It's going to give me minus 1 of those things. Those things are the same, so I can handle it.
Cool.
Same thing with 43. I got 3 of these things plus 5 of those things. That means I got 8 of those things. 44.
What about the parentheses though?
Doesn't matter. They're the same thing. 2 to the 1/3 is the same as this 2 to the 1/3.
Okay.
So if I got 3 of them and 5 of them, I got 8 of them. So the final answer on that is 8 times 2 to the 1/3.
Cool.
So as long as you got the same thing, you can add them.
Right.
Next problem, notice you don't have the same thing. I got 4√2 minus a √8. Well, that's an apple and an orange.
Right.
I can't do anything with it, but what's √8 turn into? If I simplify √8, what is that?
2.
2√2.
Yeah.
Now I got apples. So what's the answer to this?
And then so this one would be 2√2.
Yeah.
Cool.
And finally, let's finish these up. We got cube root of 40 plus the cube root of 5. Well, off the get-go, I cannot do anything with that.
No.
But is there any way I can do something with that so that I can get a cube root of 5 out of it?
Divide by 8.
Yeah. So that's cube root of 8, not divide by 8, but split up that 40 into the cube root of 8 times the cube root of 5. Then I got plus the cube root of 5.
Right.
What's that equal to?
And then that'd be equal to 9.
No, cube root of 8. What is cube root of 8?
Oh, cube root of 2.
Okay. So now I got 2 of these things plus 1 of those things gives me 3 of those things.
Yep.
So before you can add or subtract, you got to get them to the same thing. And they won't give you a problem if you can't turn that 40 into a √5.
Right.
You wouldn't have this problem. It's just like you wouldn't get this problem unless I can turn this square root of 8 into some number of square roots of 2.
Right.
So that's the secret to adding and subtracting them. Notice that adding and subtracting is completely different than multiplying and dividing.
Yeah, exactly.
I can multiply √2 by √8. That's √16. I just can't add and subtract them unless they're the same.
Okay.
All right? All right, Dylan. I'll let you go.
Sounds good.
Have a good week, and I'll talk to you Monday.
Sounds good. Thanks, Mr. Cowan.
All right. Bye-bye.